Awesome. Um, this is a video for assignment 4, design pattern exploration. This is where I had to pull it up. I had to take two design patterns and analyze them and then compare them with each other. For this assignment, I picked decoder and then composite. So for decoder, um, the problem that this pattern solves is it is able to add behaviors dynamically. So basically, what this means is if the developer wants to add new features or behaviors, they can do that dynamically without having to modify the original structure of the code. So this just basically just helps define a component interface for both the core objects and decoder implementation, as well as it creates more concrete components that can then also be implemented in the interface. But yeah, basically that's what it does. The decoder classes could either add or override behavior by just delegating to the wrapped object. This is commonly used to add responsibilities to objects without having to subclass those objects, as well as avoid having to create multiple derived classes for each. It also is able to combine behaviors, and then it is able to extend the functionality of the class in a more transparent way without having to modify the original code. Um, the advantages: it improves flexibility, so behaviors can be added and removed during the runtime. Um, it avoids a large number of subclasses to be combined to multiple behaviors, and then the trade-off is it just increases the code complexity. And then for the composite pattern, so it allows, what it solves is it allows objects to be composed into a so this mostly will just work for any application that can be divided into like divisions. So um, Developers wouldn't need to worry about concrete classes of objects to compose a tree, and then they don't also need to know whether the object is a simple product or a sophisticated box. Um, this pattern is used to organize objects into like that tree-like structure. So a lot of this you will see in file systems, an in-person or like a idea of a more common. It would be kind of like a military with the different divisions, and then the inventory system. The advantages of using this pattern, you get to work with a complex tree structure, making it more convenient. It will use polymorphism and recursion, and then it does also use the open-close principle that will allow new element types to be introduced into the app without having to break the existing app or code, basically. Now they're both they're only or they're pretty similar to each other. They both rely on recursive composition, and then they both use the open close principle, where new elements are introduced without breaking any code that already exists. The differences is the decoder just adds more responsibilities to wrap objects, and then it extends the behavior of a specific object in a composite tree. And then the composite, it has one child component, and then it adds up the children's results. And then it only works as a tree structure. So for the adding up children's results is basically, let's take an inventory system. If you have a box that has school supplies, it will just add the number of supplies that are in the box. It won't like say, okay, you have 10 pens and 5 pencils. So it'll just say in the box you have 15 items for school stuff, basically. But yeah, this is my recording. But yeah, and hope you have a good one, and I'll see you for the next one.